The alteration of motion is ever proportional to the motive force impressed and is made in the direction of the right line in which that force is impressed. This comes from Isaac Newton's The Principia in the 1600s. This is now referred to as Newton's second law. It has been reworded in the past 300 years considerably and reinterpreted in terms of acceleration. Most textbooks today state that the acceleration of an object is directly proportional to the applied net external force acting on the object and inversely proportional to the object's mass. Let's look at this in terms of the equations because it's a little easier to understand when you can see it and describe it in terms of math. The sum of all forces that are acting on an object is equal to mass times acceleration. That's Newton's second law. Now, the sum of all forces is equal to the net force. So we'll just get rid of the summation sign and say that that's the net force. And that's equal to mass times acceleration. Now, acceleration is equal to the change in velocity over the change in time for an object. Now we're going to make the substitution. So acceleration is here. We're going to substitute change in velocity over change in time for the acceleration. So the net force is equal to mass times the change in velocity over the change in time. Now if we multiply the change in time here, you get the net force times the change in time is now equal to the mass times the change in velocity. Now we call this the impulse momentum theory. F delta t is impulse, m delta d v is momentum. Mass times velocity is defined as momentum for an object. And let's break this down and change the change in velocity to Vf minus Vi and make more substitutions. So F sub n delta t is equal to mass times Vf minus Vi, and then distributing that through, that's mass times final velocity minus mass times initial velocity. And we call this the change in momentum, which is delta P. Right? Now, if we divide both sides by change in time, our overall net force is now equal to the change in the momentum of an object divided by the change in time. And this is Newton's second law written in terms of momentum. Now let's look at momentum really quickly. Momentum is by definition mass times velocity. The SI unit for mass is the kilogram. The unit for velocity is the meter per second. So 1 kilogram meter per second is the unit for momentum. And this doesn't have any shorthand form. For instance, the Newton, F equals ma, mass is in kilogram, acceleration is meter per second squared. That is given a shorthand version of 1 Newton. So a Newton is a kilogram meter per second squared, but momentum is kilogram meter per second. So the time is not squared. And that's the impulse momentum theory.